What's up, everybody? My name is Keith Gebhardt with LearnTechTraining.com, and in this lecture, we are going to go over understanding VLANs, trunks, or essentially the 802.1q protocol, native VLANs, and router on a stick, or essentially inter-VLAN routing. Now, why am I going over all of these topics as one lecture? Because I keep getting emails about native VLANs and people not understanding them. And students typically do one of two things. They get confused on them and try searching the interweb of all the knowledge out there on them, and they get more and more confused until they've ended up spending like 2 or 3 weeks on this subject, which is ludicrous if you ask me. So that's crazy. You don't want to do that. You're wasting your actual time that you could be utilizing on more important topics. Not that it's not important, and that brings me to my second reason, is because a lot of people don't understand it, but they know, okay, this is the configurations I need to make, it works, I'm just going to move on through my studies. That's the worst thing you could do, because when you get into a position and you need to start doing packet captures or troubleshooting different things happening over the network with different protocols, you're not going to know where to look, okay? You're going to be really dumbfounded. So I figured meshing all these topics together will help you make sense of it that much easier. So the first thing I want to bring to your attention, okay, some of this will be a review, and right off the bat, this is going to be a little bit more lengthy of a lecture, okay? And we're going to go over some theory, important theory, so take notes, and then halfway through it, we're also going to build a lab together, all right? And I'll put the time on the screen here if you want to skip to it. However, I don't advise you skipping right to the lab. I highly encourage you follow me through this so you have that complete and excellent understanding of this. So right out of a box, you could take a Cisco switch, right? You go online, you order a brand new switch or a refurbished switch. It comes in, you get this box, you rip the box open, you rip the plastic off the switch, and it's like that new car smell, right? It's exciting. Maybe for me, I'm nerding out over here. But you could literally take this brand new Cisco switch, okay? And that's how I draw switches. Plug any device into it and it's going to work. But why is that? Because by default, all ports on a Cisco switch are considered to be in what we call a VLAN 1. That is the default VLAN on a Cisco switch. We could prove that, actually. If I open up this, I don't want that, I need this guy. If I open up this switch right here, and let me just move it down and open it up here, I hit enter. Right now I'm in user mode, so I could go in enabled privilege mode, show VLAN brief, and you can see absolutely every interface from my gigabit Ethernets to my fast Ethernet ports are all in this one default VLAN. Pretty cool, right? But what are these VLANs, Keith? You keep talking about VLANs. I want to know what they are. Well, essentially, VLANs are just virtual local area networks. So remember, when you're studying for your CCNA, this is a CCNA focused course. You need to know of two major types of networks. We have local area networks and wide area networks, okay? LANs are layer 2, okay? And WANs are layer 3. This goes back to our TCP/IP or OSI models. And you can also relate these to being a LAN would be a switched environment, usually. And a layer 3 environment would usually be a routed network for routers, routing, IP addresses, LANs, switches, MAC addressing, okay? Very, very, really fundamental and elementary concept to understand, but I needed to drop it out there. So we have these local area networks, all right? Now, a single VLAN, being a local area network, is a single broadcast domain. VLANs virtually separate local area networks within this broadcast domain. Another way to think of this is a single broadcast domain is a single network. They're both the same thing. When you think of a different network, they're the same broadcast domain. So, for example, all right, let's go ahead and say I have a, where do I want to write this? Let's say I have a 192.168.1.0 Class C by default. So this is my subnetting range, right? And maybe I also have a 192.168.2.0 Class C subnet mask. And this is still my subnetted playground. Because of this octet right here, this is being a 1, this is being a 2, okay? They are different networks, meaning they are different broadcast domains. Let's take it a step further. If we have separate broadcast domains, we have separate networks. And that goes back to here. We have two different networks, two different broadcast domains. To separate broadcast, or to separate VLANs, if we have multiple VLANs, you could relate them to being separate broadcast domains or separate networks. This line right here that I'm putting a box around, if you understand this for the rest of your lives in networking, everything else just makes sense. And let me put this into perspective. At a CCNA level, a router is the only device that can separate broadcast domains. Now, some of you that may be already in the industry are going to argue, well, don't layer 3 switches also do it? Yes, but this is your CCNA. Remember, CCNA focus. You do not need to know about layer 3 switches for your CCNA. So with that said, broadcast domains. A router is the only thing that separates broadcast domains. If I have a router here, and let me grab blue, and if I go back and say, and I have a switch over here, we know these are local area networks to the right and left of this. Maybe this is the 192.168.1.0 network, and this is the 2.0 network. We need this router to separate these broadcast domains to communicate network A, for example, over to network B. It's going to forward that packet and information, the data that we're transmitting through our cables, our Ethernet media, to the other network. That's what we need. So if this is a local area network and this is a local area network, what do you think a VLAN is? Okay, so we're just adding VLANs, okay? If I broke this router up, so say he's 1.0 up top, and down here he's 3.0, up here he's 2.0, and down here he's 4.0. Okay, these two, this VLAN here cannot communicate to that VLAN without having a router. But these are two separate broadcast domains because this is a different VLAN, a different local area network, different network, different broadcast domain. That's why I said it's important to make sure you relate all three of these together, and it'll just make so much more sense for you moving forward. So we already noticed that we're talking about different VLANs and things of that nature. One thing I also want to bring to your attentions now is the 3 things that we must absolutely have on our networks for them to communicate at layer 2. At a layer 2, we must have an IP address, or for your CCNA, you need to know that is called logical addresses. We also need to have what we call a subnet mask, okay? And that goes back to because it's telling you which network you belong in. That is the whole point of a subnet mask. And it really mostly comes into play when we're subnetting our networks. For example, if I have a prefix of 21 for a subnet mask of 248, well, now our network range of addresses have changed, okay? So you need to be aware of that information. That way, that's why this is absolutely mandatory. Also, the third requirement is indeed a MAC address. This MAC address we do not play with. Now, okay, if you are very experienced, hopefully, some of you aren't, but you can actually hard code a MAC address. But that is way, way beyond the scope of a CCNA level understanding. Just know IP address, subnet mask, and MAC address are absolutely the 3 you need to know for a layer 2 environment. And we'll touch on this more moving forward. But we don't touch that layer 3 MAC or layer 2 MAC address because that's burned into our network interface cards on our computers. But going back to my other example up here, okay, so you can see theoretically, this is just what I did to make sense of it for you. The solid color means we are all in one VLAN, right? One broadcast domain right here. So these 2 computers will actually communicate together because of being in that same broadcast domain. Let me take the server here, open up a command line prompt, and if I just hit the up arrow, looks like I was doing this earlier. It's not gonna work. So we could just say ping 192.168.1.20. Since this computer is 1.20, I'm 1.10. Will it communicate? Bada bing, bada boom. It's communicating. It's the same network, same broadcast domain, and same VLAN. Over here, however, we are in the same VLAN. Let's prove that. Let me just open this up a little bit. And enter, enable, show VLAN brief is the command. Every port is in VLAN 1. We have no other VLANs. These are just default VLANs on the switch, obviously. But we could see that my computer here is a 2.10, and this computer is a 1.10. So logically, at layer 3 for the IP address information, the host or the server and computer are technically through their IP address and subnet mask in different logical broadcast domains. Even though the switch at a layer 2 VLAN is a single broadcast domain, do you think they'll communicate? Well, again, command prompt, we got to put this to test so you can see it. 192.168.2.10. This computer, by the way, I'm in is 1.10. So if I hit enter, bada bing, bada boom. Now, some of you may notice request timeouts initially, but you're never going to get more than one. And the reason why sometimes you'll get them initially is due to the ARP resolution protocol mapping our IP address to our MAC address. But you can see that is indeed not working. So really what we would have to do is create 2 VLANs. So if I went into the switch, CLI, and said enable, show VLAN brief, we could see we have a couple of different VLANs. okay? Now, there's no ports assigned to them right now, but for this to work, well, even for them not to work, I mean, right now, just without a router, we could have two different broadcast domains. So in the green and in the red up here, you could see that they are in, the 2.10 is its own network, and it's in a separate broadcast domain because of the green. That's a different broadcast domain. Down here, we see the 1.0 network, and he's in the purple VLAN. He's in a different VLAN. Now, these two computers would not be able to communicate together because to separate broadcast domains, okay, this is why I started the course off with this. To separate broadcast domains, we need a router, even if we have different VLANs, all right? Even if we had 3 different VLANs over here, maybe we had VLAN 10, 20, and 30, all communicating to 10, 20, and 30 up here. The only ones I would be able to communicate are 10s and 10s together, 20s and 20s together, and 30s and 30s together. And to put that into a more visual perspective, okay, I'm trying to make sense of this, guys, for you, is this. VLAN 10, these can communicate together. Like devices in the same color, for this example, will communicate together. So let me grab my pen, and let me grab black. So these guys can communicate together because same network, same VLAN, same broadcast domain. Here's where I was just explaining. Okay, we have a VLAN 10 and a VLAN 20 on this switch, but we also have VLAN 10 and 20 on this switch. As long as they are cabled and the ports are assigned to the correct VLANs, these devices will be able to communicate across the switches. So this guy will be able to communicate to this guy, but he will not be able to communicate to another network because, again, we do not have those routers. And same thing here. We have 3 examples. Each one of these will be able to communicate across the network as long as the interfaces are configured to be inside of these VLANs and they're all in the same network. Again, remember, VLANs, separate VLANs are separate broadcast domains, which are separate networks. Relate those 3 together and you will be awesome. Awesome, awesome. So it's also important to understand that there's 5 types of VLAN classifications, if you will, that you need to be aware of for your CCNA, okay? And these are, we have a data VLAN, and this is just your typical plain Jane VLAN. It's just what our regular traffic is communicating on our networks through, right? Data. We have a voice VLAN. This is a little bit more unique because now we introduce voice traffic for our VoIP over IP phones, right? And we implement different quality of service features within those ports and on that VLAN. We also have what we consider a management VLAN. Okay, now you're not going to see these listed in the switch at all. Okay, you just need to know the theoretical types of VLANs that we have, especially for your CCNA. The management is no different than a data VLAN. It's the same exact thing, except it's just separating our administration traffic, our management traffic. So only devices within that management VLAN could actually, like, for example, remote in or SSH in or telnet into a device. Not that you would ever want to use telnet, but it's an example. All right. The native VLAN. This is a trunking concept, which we'll get to more in detail in a minute. But as simple as it gets, it's for untagged traffic. And I'll go over this really well so you understand it. Finally, the 5th one is a black hole. I typically reference it as a miscellaneous, but a black hole VLAN is for unused ports. So every port on a switch, you have 3 different modes. In fact, let me show you what those are too real quick. We have 3 modes on a switch for an interface, okay? Again, this is very fundamental things, guys, but I needed to go over all of it so you fully understood it. So switch, enable, let's do config T, let's do interface F01. And if I do switch port mode, okay, so this is switch port, okay, I'm just doing shorthand mode, and I hit the question mark, you can see we have access, dynamic, and trunk. By default, all switch ports on a switch are set to dynamic, which is bad because ultimately if another user plugs a switch into their cubicle at work, right? So I'm going to draw this out because I've seen this. Actually, I've seen it in schools more so than none. You know, you get these little wall jacks. Usually you have a data port and you have a phone port, and you're sitting at your desk. You have your, handy dandy little computer here. And this is usually going to go up into a patch panel, and then we're going to run a little patch cable to our switches in an IDF closet or something, right? But really, this is our first point of contact to the outside world from our internal network. Not this here, because this is where it's plugging into the switch. The patch panel is just like an extension. It's just a coupler. It's like plugging a male and female end of a cable together, right? That's all that is. But what if you're studying for your CCNA and you have a beautiful little 2960 switch here and you're like, ooh, I just learned something today. I want to play with it. I'm going to plug it in here and see what I can do with it, right? Boom, bad. If this is not formed or set to access and he starts going in and configuring trunk links and things of that nature, well, he could potentially take down the entire network, especially if they're running something called VTP, which is a virtual trunking protocol. Okay, this is beyond the scope of this course, but it's bad. So what we do is we take all unused ports and put them into this black hole VLAN. But we're going to change the mode to access so they cannot form a trunk link. And as a secondary security precaution, we also shut them down. You can think of these black hole VLANs like real black holes. They're out there. You know they exist just from science classes and things, right? But can you see them? Not really, right? If you just put that into a little crazy Einstein conceptual idea, it's all they are. There's no real, hard, unbelievably difficult reason to understand them. They're there for a security purpose. Just so if someone plugs into them, you can't access them. They're in a different network. All right, I'm done with that. What is the benefit of multiple VLANs? Well, it creates smaller broadcast domains because that talks about the address resolution protocol, where it's sending out broadcasts saying, hey, I'm at this MAC address. What's your IP address? By the way, this is a layer 2 protocol. A lot of people get this mixed up because it's mapping to IPs, but it is a layer 2 protocol. We'll go over that in a minute more too. So smaller broadcast domains, okay? If I have one network here with a bunch of devices on it, this ARP has got to go through all these devices. However, if I'm sending an ARP from this computer out, and I have a bunch of devices on the network over here, none of these guys are going to receive it. So it splits up our broadcast domains. It creates a higher efficiency of traffic going through our network, okay? And it also helps prevent broadcast storms. So let me go ahead and clear the screen here, which brings me to my next point. 802.1q trunking, or 802.1q is a trunking protocol. It uses tagged VLAN information to transmit data across Ethernet. Again, we'll get back to that. Now, the benefit of trunking is instead of having, one cable for every network, we have 2 VLANs here on both switches, we have to run 2 cables. We have 3 VLANs over here, we have to run 3 cables because that cable's got to be in each of the VLAN that these devices reside in, right? Absolutely. So now we could actually manipulate or reduce the amount of wasted ports on our switches by just using one port as a trunk link that will carry all of our tagged VLAN traffic over. I keep saying tagged and untagged. All right, I'm getting to it. With default native VLANs, it's for untagged traffic. Okay, let's go ahead and scroll down over here. Yes, this goes back to very basics, guys, but so you understand it. So we obviously know we have data encapsulation, right? So if I'm trying to create an HTTP session, this data block is going to get encapsulated with TCP or UDP, but HTTP is TCP at what port? 80. That's going to get encapsulated again with a source and destination IP information. By the way, this is called a segment. This is called a packet. And this is called a frame. Okay, layer 2. And then all this information gets encapsulated into our frame. What does this frame? Remember, switches are not concerned with layer 3 at all, so no IP. Switches do not care about IP address information, but they do care about layer 2 information, MAC addresses. So this is our frame. Since we are talking about switches, you have a preamble, start frame delimiter, destination MAC address, and source MAC address, which are really the 2 major ones you need to know for your CCNA, plus the data, which would be all of. So the data block basically just encapsulates everything here into this data block right here. 1500 is your MTU, or maximum transmission units, and then the FCS field your frame check sequence for more or less noticing if there was an error of transmission across the network. All right, so this is your standard default frame. This is what it looks like when you capture a packet. With a VLAN tagged frame, we are adding this little sliver into it called the tag, which is going to include the VLAN ID. So as we send a frame through the network, it goes into the switch, the ingress port. The switch is going to say, oh, this interface is associated to VLAN 10. So on the egress interface going out over a trunk link, okay, a trunk link, the switch is going to throw this tag into it. So when this switch receives it, it says, oh, this is meant for the 10 network or the VLAN 10 subnet broadcast domain. I'm going to send it over there. And it does this because what if it needs to send out an ARP? What if it doesn't know where this resides on and we have multiple hosts? So instead of saying ARP to everybody, since the VLAN is separating broadcast domains, it just sends it to what it needs to. But even if this VLAN, even if the switch knew where he existed in the MAC address table, it's going to say, okay, VLAN 10, send it to this side. Here's the host it goes to, and bada bing, everything's good. That computer could receive that information. Pretty cool stuff, guys. But we got to take a step further. Over this trunk link, we introduced that native VLAN. Now, remember, native VLANs are only relevant when we are talking about trunking. Okay, we do not need to concern ourselves with native VLANs whatsoever unless we are trunking. Going back up here, all right, on a Cisco switch, by default, VLAN 1 is the default native VLAN. We usually change this, and it is recommended that you change it for security purposes. Again, you do not ever want to leave a device just default. One reason is, like, even if you're not going for your CCNA and you're not learning all this, but if you go into a building, right, like I manage a lot of Juniper stuff, and it wasn't until just recently I started teaching Juniper. But before that, I would have to just go onto Juniper's website or other resources available online by Googling and trying to figure out the command syntax and all that and how those switches operate. Well, what if you are Juniper certified and not Cisco certified and you have Cisco equipment? You're going to do the same thing I did. You're going to go to Google and you have to figure it out. That is your job as a network engineer. So people by default, as a network admin or analyst or engineer, know every port on a Cisco switch by default is in VLAN 1 and that its default on VLAN for native VLAN is 1. So that's bad, especially if you are a hacker, with malicious intent. All right. And if you don't, make your network secure or harden your devices properly, it's a security vulnerability. So that's why that should be changed. I went on a little rant there. I apologize. Okay. I'm trying to give you all the information I can in as little of time I can, but as well as it makes sense too, So next we have VLANs use either ISL or 802.1q. Now both of those, ISL and 802.1q, are two types of encapsulation protocols we have on our networks. ISL is Cisco proprietary though, and it's the older version. The 802.1q, or typically we just reference it as .1q, okay, slang, and that's actually the configuration is .1q. That's the IEEE standard. It's the newer version. It's now multi-vendor where ISL was Cisco proprietary. But you know what's funny? Even though ISL is Cisco's, guess what Cisco recommends you use today? 802.1q. Just makes everyone's life a little bit easier, all right? So, as a recap with everything we learned, because of these parameters, all right, all ports on a Cisco switch are by default in VLAN 1. Remember, a VLAN is essentially a broadcast domain, which is essentially the same thing as a network, okay? If you guys remember this line, you'll be golden, all right? Promise you. A single VLAN is a single broadcast domain, and VLAN 1 on a Cisco switch is the default native VLAN. This is the reason why switches work right out of the box with no configuration necessary. That's why we have to go in and manage these. You never want an unmanaged switch in a important network infrastructure. Yeah, I know you have different Linksys Netgear hubs that people just plug in and play. Even Cisco switches, I've seen it. I have seen it. They just plug them in the closet and it's like, boom, they just go away, disappear. It's crazy. But that's not what you want to do. So that is VLANs, 802.12 or 802.1q trunking, native VLANs, and now let's talk about inter VLAN routing. Essentially, with that trunking concept, we are just taking a router, cabling it to one of the switches, and allowing this VLAN to communicate to this VLAN, because again, these are separate broadcast domains and vice versa. Doing so we obviously know we are plugging into a physical interface. So say we're plugging into interface F00. We actually have to create a sub interface. So when we type out this command, we're actually going to say F00 dot maybe 10. And then 0.20, and then maybe 0.30. You can name these or number these whatever you want, but you typically want to keep them in relation to the VLAN and the network, all right? Because one, documentation can get really messy, and when you're doing show commands, you want to be able to, find issues, if you're troubleshooting an issue, you want to be able to find a resolution as quickly as possible. You don't want to be fooling around saying, well, this doesn't make sense. Why is this interface 0.15 and it's VLAN 10 with a whatever network? Like you want to try to be consistent with these. So in doing so, we're creating these sub interfaces. We're going to tell them an IP address, and we're also going to say encapsulate. Okay, and when we're telling them to encapsulate, we're using that 802.1q. All right, very simple, very easy. Let's go ahead and start configuring these. I'm excited. Are you guys excited? Get hyped. We're going to build some networks right now. If you guys do not already have this topology created, go ahead and create it. All right, it's very simple. I have two 2960 switches, and I'm going to be using one 1841 router, just like that. Right there, just like that. You can see the computer addresses, all right? So once you get them all cabled up, pause the video, cable it up how I have it here. In fact, I'm missing a cable, so I will cable this router. We're going to go from FA01 to FA01 on that switch, all right? So cable them up, and we will go through configuring and setting these up together. All right, pause the video. All right, welcome back. Let's go ahead and get started. So first computer, desktop. We're going to address together 172.16.1.10 with a class C subnet mask. Oh, see how it defaults to B? We're going to change this to C. And so we're subnetting right now because we're playing in the third octet, not the second. So we need to give it a class C subnet mask, right? The default gateway for each one of these networks is going to be a .1. So all I got to do is say 172.16.1.1, and he's good to go. We're going to go ahead and do that for VLAN 20, desktop, IP configuration, 172.16.2.10, 255.255.255.0. We're going to do a 172.16.2.1, and he's good. Bada bing, bada boom. Let's go to this guy. We're going to address him, and let's see. It's going to be 172.16.3.10, 255.255.255.0, and again, 172.16.3.1. Bada bing, bada boom. Let's go to these guys. We're going to go over here. And just for the sake of this lecture, to keep the time down, we're already running up close to a half hour. I'm only going to address the VLAN 10 computer right here. Alrighty. So 172.16.1.20. Again, class C, 255.255.255.0, 172.16.1.1. All right, now the fun stuff. Let's go into our switch and configure the switch. All right. First thing we need to do is go into the CLI. Let's go ahead and go into global configuration mode. To do that, we say enable configure terminal. Boom. We're going to say we got to create our VLAN. So we're going to say VLAN VLAN 10 name, I don't know, HR. VLAN 20 name, staff, whatever, doesn't matter. VLAN 30. We can name sales, and then whatever. Let's do a VLAN 40 for native. Beautiful. Exit that. Now we need to assign our interfaces to those VLANs. All right. So let's go ahead and say interface FA02. That's for my top computer there. We're going to say switch port mode access. Enter. We're also going to say what? What do you guys think? Switch port access VLAN 10. We got to tell that interface to be associated to that new broadcast domain. We can exit this. Interface F03. And then we're going to do a switch port. Again, that's just shorthand. If you tab it out, it says switch port mode access. I'm just hitting my tab key. Switch port access VLAN 20 for this guy. Right? 3, 2, 3, 4, 5. Yeah. All right. Just making sure. And now we can exit this. It looks like interface F05 for me is going to be switch port mode access, switch port access VLAN 30. Gorgeous, gorgeous. So this switch right now, as far as my VLANs and my interfaces here for my user network are configured. But we need to also configure our trunk port. So let's go ahead and do that. We're going to go ahead and configure interface F04, switch port mode trunk, so it's no longer dynamic, right? Switch port trunk, and if you hit the question mark, you see we're going to use a native question mark VLAN and the ID. So we're going to say What did we use? 40? I believe we used 40. Good. So we're good with that. Exit. Now for a security measure, let's do it. Let's go ahead and create that VLAN. I don't know. Let's just say 100 and name it black hole, whatever you want. And we could go ahead and say show IP interface brief. Do show IP interface brief because we're in global config mode. So we have 1, 2, 3, 4. Do we ever use Festing.01? No, we didn't. Interesting. Anyway, so we're going to put ports 6 through 24 into this black hole, just so you guys can see how I do it. I'm going to do a interface F06 through 24. I'm sorry, we got to say range. Interface range. Enter. Shut down. Shut down. We're also going to say switch port mode access. Switch port access VLAN 100 for that black hole VLAN. We could exit this. Do show VLAN brief. And we can see we put all those unused ports here. Right? Now we still have these, but just to keep the video short, I'm not going to go back and go through all those. You can play with it. Practice this. But we see our 3 main ones, and we also see our native VLAN. Now up here, you did see a native VLAN mismatch. It's going to keep yelling at me until I correct it on the other side, and that's why the link is down right now. So let's go ahead and go back. And that actually brings a good point up too. Both switches need to be in the same native VLAN to form a trunk link. And that's why we don't want to leave it in default VLAN 1, because if someone is indeed playing around with the switch, practicing, or someone maliciously trying to access or form a trunk, do something on our network, if it is native by default VLAN 1, they could easily get to it. At least if we configure something different, right, then it'll be a lot more difficult for them to try to create a VLAN with them. All right, just a little FYI. So this switch right now is good. Let's do a copy running config or run start. Okay, that's saving our running configuration to our startup configuration. That's how you save it. Let's go to the other switch over here. Very similar thing, except it looks like I'm using FA01, 3, and 5. Okay, so let's go in here. Still, we're seeing this native VLAN mismatch. It's fine. We'll fix that here in a minute. Config T. We need to do VLAN 10, name HR, exit VLAN 20. What did I name this? Name staff, maybe? And then we could do VLAN 30, name will be sales, I think it was, and then VLAN 40 will be name native. Beautiful. And another thing with that native VLAN, you're also noticing how until we assign that trunk interface to be associated with that native VLAN being 40, remember we gave it that command, then it's not gonna work. So let's go ahead and fix this. Let's go ahead and say interface F01, switch port mode access, switch port access VLAN 10. Exit this, interface F02, or it looks like I messed that up. It's going to be interface F03. It's going to be switch port mode access, switch port access VLAN 20. Exit, interface F04, nope, 5. I don't know why I did it like that. That's weird. I usually never do it like that. But oh well, we'll manage. Switch port access VLAN 30. Exit. Interface F04. I keep saying G. I'm used to working on gigabit Ethernet. 4. Switch port mode trunk. Switch port. Now look at all the possibilities you have. But we have a trunks. And then we could say native. Oops, see? Mismatched command. Native. VLAN 40. Boom. Alright, so it's now unblocking it. Port consistency back up. Our trunk link is indeed working. So, we are good right here for now. But before we get to the router, I want to test connectivity. It's always good to test connectivity as you build configurations because you need to be able to find an isolation point, for an issue. You don't want to completely build a complete network and then running into issues, and now you have to go back, step by step all the way through to figure out where it exists. So at least as you do it, as you progress within your design, you could start isolating, right where you left off if you run into an issue. Just my little 2 cents. So on my computer 1.10, I'm going to ping 1.20 over here, 172.16.1.20, and I should have communication. And the reason why I should have communication is because they are in the same VLANs. They are in the same broadcast domains over this trunk link. Ooh. Let me just double check the configurations. 16.120. What's this? 16 timed out on me, boys. Alright, so we made a mistake. 16.110. Class C. Did I forget a configuration? Let's double check our Fast Ethernet 04. Alright, so let's do show interface trunk. And okay, we are trunking. VLANs are allowed on 110, 20, 30, and 40. Okay, we're good. And let me just do this. Oh, he's not port 1. He was port 2. Okay. So that's an easy fix. Let's go back in here. Let's go, I don't know what switch that is. So let's just open him back up. And let's do this. Let's go back to interface F02, switch port mode access, switch port access VLAN 40. We're gonna, actually, I'm sorry, exit that. Interface F04 is gonna, what am I doing? Exit. F01. We're gonna put that 01 back into a black hole VLAN. So switch port mode access, switch port access VLAN 40. Alright, I'm losing my mind, ladies and gentlemen. Alright, there we go. So now we can go to interface F02, switch port mode access, switch port access VLAN 10. Okay, we can exit this, do copy RS, save it. Now, once spanning tree comes back up, remember, spanning tree, it's going to take a few seconds. Once that comes back up, we will be able to communicate. Fast forward, go to this computer. We'll use the same computer. Command prompt. All I'm going to do is hit the up arrow, 1.20. There we go, communication. All right, that's a good example. You know, when I make mistakes, I try not to cut the videos because you guys need to be able to see. You know, and the more troubleshooting you see, the better it is for you. Remember, your CCNA exam is going to be mainly comprised of actually troubleshooting and viewing show scripts. And when I say show scripts, I mean when I went up here and said show trunk or any of those show commands I was doing, right? It wasn't on this switch. But any, like show or do show VLAN brief. They'll give you printouts like this. Or do show ether channel. Here, let me exit this. Cisco packet tracer is not like real Cisco iOS. Show ether channel, okay? You'll need to know that. Or actually, summary will be one that you really need to know for when you start learning about port channel and stuff, right? So those are, you'll get different printouts on the screen that show this information that you need to be able to do your work and answer those CCNA questions. That's a little FYI. So we have communication through these broadcast domains, but if I took this computer and tried to ping the 16.2.10 computer, will we be able to? 172.16.2.10 and failure. Why? Because they are in different broadcast domains. To save time, I'm not going to let that sit there and cause timeout. Let's go ahead and configure this. So we need to configure this link here to be a trunk as well. Let me open this baby up here. All right, we're going to go into config T. We're going to do interface F01. We're going to do switch port mode trunk. Actually, let's get this out of black hole VLAN. We're going to do switch port access VLAN. We could put it in VLAN 1 because it's not going to be associated with that once we put it into a trunk state. All right. Now we could do interface F01. I don't know why I left that. We're going to do switch port mode trunk. All right. We're going to do a what? Switch port trunk native VLAN. And what was it? What was our native VLAN? 40? Was it 40? Let me open up this switch. I forget. Do show VLAN brief. And our native VLAN was 40. Yes. Alright. Native VLAN 40. Boom. We are good. So that is now a trunk port. But notice it's still red. That's because the interface on the router is not configured. So going over to the router, let's go into the CLI. We're going to say no here. Enable configure terminal. And now all we got to do is say interface F01. But we're not going to just go to F01. We're going to do 1.10 subinterface. And you know that by it saying config subinterface right here. Here, we need to give it an IP address of 172.16.1.1, 255.255.255.0. We're going to do an encapsulation 802.1, actually it's .1Q, VLAN 10. I'm sorry, not VLAN 10, just 10. There we go. I'm so tired from moving all week. I'm moving offices, actually. All right, so encapsulation .1Q, everything is good. All right, so we also got to do the IP address. Cisco Packet Tracer is a lot different from real Cisco iOS. It's very similar, but you get away with a lot more things. Like, this is forbidding me from doing this. You know, it's what it is. So I'm just putting that back in just so it works. Now we can go into interface F01.20. All right, we're going to do encapsulation .1Q20, and then we're also going to do IP address 172.16.1. Or I'm sorry, 2.1 with a 255.255.255.0 and exit. But these are virtual sub interfaces. They're not known as virtual interfaces. They're just non-existent, interfaces. We created them within iOS, okay? Software interfaces. They're sub interfaces. The physical interface we're actually plugged into is not configured. So we actually still have to go back to interface F01 and do a no shutdown. And as soon as spanning tree is done, this will indeed come back up right here, and we will be able to communicate with the router. Pretty exciting stuff, guys. Let me just fast forward this so we don't sit here all night. Let me go ahead and take this computer, command prompt, and let's just try to ping our default gateway first. Ping 172.16.1.1, and we have communication. So now I will be able to communicate to 16.2. So if I hit the up arrow, 16.2.10, whatever, enter. Again, it's got to send that address resolution protocol, so one packet may drop, and it's going to come back. Ladies and gentlemen, that is VLANs. That is trunking with the 802.1Q protocol. That is the understanding of native VLANs. Okay, so VLAN traffic gets a tag, so the switch knows about where it's going when another device, not even just a switch. So a switch will tag it with that VLAN ID. So anything going over the trunk will know on the other end, whether it's the router or the switch. We have our native VLAN, which is untagged, basically just your standard Ethernet frame going across, okay? And again, that's for our controlled traffic. That does not need a VLAN tag. And then, obviously, we gave you this quick demonstration on how to configure an inter VLAN routed network, or a router on a stick. All right, guys, so I hope you really found this informative. Please subscribe to this video if you liked it. And do not forget to check us out on Facebook. Subscribe to the page, like it. I'll see you guys later.